API gateway. An API gateway acts as a single entry point for all client requests. It routes them to appropriate backend services, reducing direct coupling between clients and microservices. It can also handle authentication, logging, and load balancing. Saga pattern. The Saga pattern handles distributed transactions across microservices by splitting them into smaller local transactions. Each service performs its transaction and publishes an event to trigger the next. If a failure occurs, compensating transactions roll back the changes. Circuit breaker. The circuit breaker pattern prevents a service from repeatedly invoking a failing service. Once a failure threshold is reached, the circuit opens and calls are short-circuited. This avoids cascading failures and allows the system to recover gracefully. Aggregator pattern. The aggregator pattern is used when a client needs information from multiple services. It collects responses and returns a combined result. It can be implemented in the API gateway or a dedicated composite service. Strangler Fig pattern. Inspired by how a strangler fig tree grows around its host, this pattern allows replacing a monolith gradually. You develop new functionality as microservices while retiring monolithic parts one by one, reducing risk. API composition. API composition is used when data from multiple services must be combined. A composer service fetches data from each service and aggregates it into a single response, often used in read operations with database per service architectures. Sidecar pattern. The sidecar pattern attaches a helper component, like a proxy or logging agent, alongside a microservice in the same host or container. It offloads responsibilities like service discovery, logging, and configuration management without modifying the service. Choreography, Saga. In the choreography variant of the Saga pattern, each service listens for events and emits the next event in the chain. There's no centralized coordinator, promoting loose coupling but requiring careful design to avoid complex dependencies. CQRS. Command Query Responsibility Segregation, separates read and write operations into different models, optimizing each for its workload. It's useful in high-scale systems where reading and writing require different performance and consistency strategies. Retry with exponential backoff. Blind retries can cause a retry storm and overload downstream services. Exponential backoff increases the wait time between retries, reducing pressure on the failing service and giving it time to recover.